Hello, welcome to today's video on section 14.3. So section 14.3 is called Verify Trigonometric Identities. An identity is basically an equation which one expression can be expressed as another expression. So for example, cosecant theta could be expressed as 1 over sine theta. Secant theta could equal 1 over cosine theta. Cotangent theta could equal 1 over tangent theta. These we know. Tan theta can equal sine over cosine. We've talked about this. And since cotan is reciprocal of tan, it could be cosine over sine. If you flip over this one right here. We've also talked about sine squared plus cosine squared being equal to 1. That's because of the unit circle. The equation unit circle is x squared plus y squared equals 1. And if you plugged in y for sine theta and cosine theta for x, you would get that. And by the way, when you see sine squared theta, it really just means sine theta and then squared, just so you know. There are a few new ones here. These two can be obtained by doing the following. Divide sine squared theta plus cosine squared theta equals 1 by cosine squared theta. See, if I were to take this equation right here and divide both sides by cosine squared theta, look what happens. 1 over cosine squared becomes secant squared. And then over here, you have sine squared theta over cosine squared theta, and you have cosine squared theta over cosine squared theta. And that just becomes 1, and that becomes tangent squared theta. So that's how you can derive this formula right here. And then this one, if you divide sine squared theta plus cosine squared theta equals 1 by sine squared theta. If you did that, you would wind up getting this equation. And these, by the way, are called Pythagorean trig identities. The last two rows, these are called the complementary identities because they're subtracting pi over 2 with the angle, and pi over 2, remember, is like 90 degrees. Plus cosine really means the complement of sine. And cotangent means the complement of tangent. And lastly, these are the negative angle identities. These work the way they do because if you think about it, let's say you have 30 degrees. We know the coordinates here is going to be root 3 over 2 and half. Let's say you do negative 30 degrees. Now the coordinates are root 3 over 2 and negative half. Notice how, since y is sine theta, notice how the signs change here. Hence, sine negative theta is negative sine theta. But the x-coordinates, because x is cos theta, they stay the same. So if you cos negative theta, it's still cosine theta. And then lastly, tangent is y over x, the x values stay the same at 30 degrees, but the y values obviously change sign, so naturally tan negative theta would be negative tan theta. We'll use these identities to do the problems that follow. So let's look at the first example. Tan pi over 2 minus theta times sine theta. That's example 2 on page 925 in the book. Well, tangent pi over 2 minus theta we know is cotangent theta. And cotangent we know is cosine theta over sine theta. And those will just cancel. So the answer is just cosine theta. So the strategy is to convert anything that's not sine or cosine to anything that is. Let's look at number 2. So using the same strategy, it's 1 over sine theta. Cotangent squared is sine squared. Oops, my bad. Cosine squared theta over sine squared theta. And you have 1 over sine theta right here. So that becomes cosine squared theta over sine cubed theta. And then if you see an opportunity to combine fractions, you probably want to do that. So then you get cosine squared theta plus sine squared theta over sine cubed theta, since sine cubed theta would be your LCD. And remember, cosine squared plus sine squared, as we saw over here, is just 1. So it's 1 over sine cubed theta, which in essence is really going to be cosecant cubed theta because you're doing 1 over sine. So that's how you simplify. Okay, now let's talk about verify. Verify means you want to prove that one side equals the other side. That's all that means. So, and the strategy here is choose the more complicated side to simplify. So I see secant squared theta minus 1. If you think about it, if you were to take this equation right here, let me highlight it. Here we go. This equation right here, and subtract the 1 over, that'll give me tangent squared theta. So that becomes tangent squared theta over secant squared theta. Then if I convert everything to sine and cosine, and then flip over the bottom fraction. Remember, you're dividing by fractions, you always want to flip over the fractions on the bottom. Those cancel, and now we have it verified. So the strategy is to choose a more complicated side to simplify, and then of course the strategy for simplifying is to convert anything that's not sine or cosine to anything that is sine or cosine. Okay. Now, number 4, that one's a little tricky because it's not quite obvious which side's more complicated. Let's choose the left side, though. The reason why I'm choosing the left side is because those don't have sine and cosine. The right side does. So that's 1 over cosine theta. And that's, actually, we'll just use x. And sine x over cos x. Then I get 1 plus sine x over cos x equals that. Now this requires a little bit of craftiness, but what if I had done something like this? I have that, and at the bottom I have this. Why do I do that? Because I have cosine x in the numerator, so I must have cosine x in my numerator here. And instead of doing the top and bottom for the left fraction, that's fair treatment. Now the bottom becomes this. That's just using this property right here. So cos x 1 plus sine x, factor the bottom, cross off, and you have just this. Now you might be asking yourself, how come I didn't cross multiply to make this true? To verify this identity? One restriction that I will impose, just because I want you to use the identities, one restriction, you can only work on one side. That's my rule. I know it's cruel, but so be it. Okay, so I'll end the video right here. Not too long. I had to go kind of fast because I have a dentist appointment actually right now, so I'm actually late. But that's all right. They'll still work on me. Anyway, all done. And I'll post some questions to the Google Doc form, and we're all set. See you guys tomorrow, or Wednesday for G period.